Hello and welcome back to another Python tutorial. So we're continuing our series on machine learning. And so the last topic we covered in this, well, really it was our first topic, was simple linear regression analysis. And so with linear regression, what we're trying to do is we're trying to model the relationship between two variables. So we have our x variable, also called our exploratory variable, and we're trying to model the relationship between that variable and another variable called the explanatory variable, also called our dependent variable or our y variable. And so the nice thing about that model is it's very easy to interpret. It's very easy to build, and it's one of those models where it doesn't take a lot of effort to kind of get it up to speed and going. But unfortunately, one of the drawbacks of it is, well, what happens if there is more than one particular variable at play that could be impacting your dependent variable? And so that really kind of leads us into our next particular model, which is going to be a multilinear regression analysis or multiple regression analysis. And so the idea behind this model is it's really just kind of an extension of our simple linear regression analysis. But now what we're going to allow for is we're going to allow for multiple exploratory variables. And so we're going to try to model the relationship between multiple exploratory variables with a single explanatory variable. And so what this will now allow us to do is ideally model more complicated phenomenons, because the reality is there's a lot of things that can impact a particular variable, especially when you go into things like economics, psychology, finance, just science in general. There's a lot of different things that can impact one particular variable, and so having a model that can allow for that level of complexity will hopefully make the model more accurate. So with that being said, what we are going to be covering as our example is, I do know we have a fairly large following from Korea. So I wanted to talk about a particular topic related to the Korean economy. And so we're going to try and forecast GDP growth in Korea given a few exploratory variables. And so the reason I chose Korea was actually pretty simple, because I actually studied econ in college, and Korea is kind of the poster child when it comes to GDP growth, at least, historically, because basically right after the Korean War, they were in poverty. I mean, the country was pretty much in poverty, which is expected. Any country that comes out of a major war is usually not in good standing, but they did something pretty remarkable, which was they took themselves completely out of poverty into one of the top 15 economies. And they did it in about less than 50 years, which is truly remarkable, because it's very hard to find similar countries that have been able to do the same. And so it kind of became this interesting phenomenon that a lot of economists study, which was, how did this country do that? I mean, how did this country, experience such phenomenal growth that allowed them to basically become the country that they are today? Now, and there's a lot of debate, was it good? Was it bad? Like anything, it's a little bit of both. I mean, obviously it took a country completely out of poverty, but then there might have been consequences to that. And so I thought it was an interesting topic, and it kind of fits in nicely when we're talking about multiple regression analysis. So what I did is I went to the World Bank and I downloaded a data set. And so this data set has a couple different things. The first thing that is very important to us is GDP growth. And so this is the variable that we're going to try to predict. And then these are all the exploratory variables that we are believing has an impact on that particular explanatory variable. And so it's things like consumption expenditures for both the government and consumers, things like that. So the idea would be, if you're consuming more, then GDP growth should go up. We have things like unemployment. So if unemployment's low, maybe the economy is more productive, so you would have more GDP growth. We have gross capital formation. So if you're producing more capital, then what that is maybe telling us is, hey, then the economy is more productive, so you're going to have more growth, for example. And then we have things that, kind of make sense. So things like population growth, broad money growth. So this is just the money supply. So if there's more money available to people, so the actual, money supply, then you can go get loans easier. You can go take that money, invest it in businesses to produce capital and things along that nature. So for the most part, most of these variables make sense, and the range of this data set goes from 1969 to excuse me, 2017. And so a good range of values. And what we're going to try to do is model this relationship. We're going to try to see what's the relationship between our dependent variable with our independent variables. And we'll see that we're going to have to transform the data set and things along that. And we're also going to be removing variables because we're going to see that they're highly correlated with each other. And that's a topic that we're going to discuss because it will impact our model. So with that being said, I am going to jump in back to my Jupyter notebook. And so the first thing is well, I do want to kind of tell people that I will be releasing the Jupyter notebook when I release the videos. I will say I'm probably going to make a couple changes to this just because I'm kind of picky about wording. And so sometimes I like to sit on it before I actually release it. Well, not release it, but, editing it. And so just expect there might be a change to this, but generally the code is going to stay exactly the same. It's just kind of more the explanation about particular topics that I might be changing. We're going to be using a bunch of libraries. Shocking, right? Some are going to be used for visualization, so things like that. We got Seaborn and Matplotlib. These are both going to be used for visualization purposes. We have Pandas. So Pandas is obviously used for our data frame and loading and transforming our data. NumPy for certain calculations. PyLab is for another type of visualization. Math is for computing certain metrics. Stats, again, certain metrics. The stats model API, this is a great library when it comes to evaluating your model. Otherwise, we would have to compute all the metrics by hand, and we don't want to do that. We just want to kind of leverage something that's already been built for us. And then we're going to actually model the data using sklearn, so popular machine learning library. So this will all be in the code. I'm going to run it just to make sure it loads. Wonderful. And then from here, we can load the data into Pandas, so that way we can easily manipulate it. And of course, I have a bunch of notes on my desk, so if you hear things in the background, that's just me moving stuff around because that's how I do things. Okay, so the first thing that we're going to do is we're going to load the data. So we're going to load the data. If I can type into Pandas. Very straightforward. We're going to create a variable that will hold our data. We're going to call it econ_df, short for econ data frame. We're going to call it Pandas library. Read_Excel, so because it is an Excel file. The name of the file that we're going to be loading is going to be korea_data.xlsx. And then once we do that, we can just take a look at it just to make sure it's all good and dandy. And of course, I still have it open. I probably should have closed that. Alrighty. Wonderful. So we get this wonderful, huge data set. The first thing here is we do want to replace certain missing values. So the missing values do pop up as ... And so what we're going to do is we're going to do econ_df equals econ_df, and it's going to be replace. Oh, not like that. Econ_df. And then it's going to be ... And then we're going to replace it with a non-value. So it can be just lowercase like that. And again, if I do that, oh, I forgot to replace. I thought I typed it out. I guess not. And so now they've been replaced with non-values. And really, for the most part, that was just kind of for demonstration purposes about replacing missing values. I'm going to be working with the data set going up to 2016 just for kind of the ease of use, if you want to call it like that. So we'll see that later when we just select certain rows. However, we do need to set the index because right now it's 0, 0. I want the index to be the year column. So that's what we're going to do next. So we're going to set the index equal to the year column. And from here, it's going to be econ_df.indexProperty equals econ_df. And then we're going to select the year column, and that is uppercase. And then what you'll notice is if we call it, the year is now the index, but unfortunately we still have the old year column there, so we need to drop that. So we're going to again call econ df, and then we're going to call the drop method, and then we're going to say drop that year column along the columns. And then ideally, that should work wonderfully. So we'll do econ df. So the old year column is gone. So now it's just the year index. That looks great. I will do one final conversion. I'm going to make sure everything is a float value. Everything in here can be a float value, so that's okay. It's very straightforward. Again, this is going to set the data type of the data frame. And then so it's going to be econ df equals the old one after we've applied a transformation. So just say, make sure everything is a float. And then what you can do, d types, you can now see everything is a float object, just like we want it. Okay, so from this point, like I said before, I do just want from 1969 to 2016. The reason why is we do have a missing value. I rather just not work with the missing value at this point, so I'm just going to kind of only select the ones that have a full value range, and everything else is good to go. So we can just select those columns. So we're going to call the old data frame, we're going to call the location method, and then we're going to say from 1969 to 2016. And so what we should see is now 1969 to 2016. So we got rid of 2017. Now, as much as I love these column names, they are a little bit long, and so kind of for purposes of speed, I will rename them. However, I'm going to be using existing code that I've already typed up just because I don't want to kind of waste my time typing all of that. Again, it will be in the Jupyter notebook. Dun, 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 dun. Yeah, that's what I'm talking about right there. Took a while to type that. Okay, so basically all I'm doing is I'm just shortening the name. So I'm taking something like this and just changing it to unemployment, things like GDP growth, along that nature. So we're just going to rename the column. So rename the columns, and this should be pretty straightforward. Econ df equals econ df, and then we're going to call the rename function. I'm going to pass through a columns parameter, and that's going to equal the new column names dictionary. So the key is the old name, the value is the new name. And then after doing that, we should be good to go. So everything got changed just like we were expecting. Again, one final thing that we should usually do is we should check for nulls just one final time, especially with larger data sets. It might be a little bit hard to find it. And so I'm just going to do some display stuff. So I'm going to say display that, and then I'll just want 100 of those little dashes. So I'm just going to do it like that. And I'm going to say display if there's any null. So I'm going to say econ df. I'm going to call the isNull function, and then I'm going to call the any function, and then just like that. If it says false, that means there are no nulls. If it was true, it would mean there is a null there. So every column has no null. So that's very good. I'm happy with that. And then finally, let's just give something back to the user. So we're going to say print the head. So the first 5 rows. And so I got this, and then I got the first 5 rows, so that way the user can easily tell what the columns are, and if there's any kind of information like that. So with that being said, though, I am going to kind of cut the video off right here. Don't worry, there's more videos, trust me. So if you have any questions about kind of just the overall idea behind the model, or any of the steps that we did to load the data into Pandas and any of the transformations, please put them down in the comments below, and I will try to get back to you. Also, if you could make sure to like the video, we always appreciate the support. And if you're not already, please make sure to subscribe to the channel. So we will see you in the next video where we continue on, but now we're going to start doing some exploration of the data. So see you next time.